Variable acceleration and vectors. So last tutorial, we looked at variable acceleration in one direction, so moving in a straight line. Very tough question, by the way, you should check it out. Now we're going to look at how it works in vector form. Reasonably simple, well, not reasonably simple, sorry. It's basically the same, it's just we're looking at I and J components. So here we've got a hot air balloon flies near a barn located at the point 12, 0 in the XY plane. The balloon's displacement from the barn is that, where t is measured in seconds. Write down the position vector r of the balloon relative to the origin. Okay, it's only one mark. Let me give you a diagram to just help you understand what's going on here. So we have an XY plane. We have some balloon flying around the place. And it says that there is a barn at 12, 0. And it says relative to the barn, so relative to this position, the balloon is doing whatever that balloon is doing, yeah? So the balloon is doing this relative to the barn. They want to find out its displacement relative to the origin. Well, that's pretty simple. All we're doing is we're saying, okay, relative to the origin, the position vector of this is 12 plus this, okay? But that 12 is only on the I component, all right? So you're adding, as a vector, 12, 0 to that. Okay, now I like to write these things as column form because it just looks better. Forget I and J. In the exam, guys, you can use them interchangeably. So for one mark, all we're doing is we're adding 12 to the I component. So R now becomes 12 minus 28. 12 minus 28 sine of pi over 720t. And then the Y component doesn't change. So that's 40 minus 40 cos of pi over 720 t. And that's in meters. Write down the position, at time is 400. Find the distance between the balloon's distance from the barn and the distance from the origin. So if we go back to my sketchy sketch, so this is 12, this is 0. After, 400 seconds, the balloon might be here. All they're saying is work out this distance, d1, and this distance, d2, and just work out the difference between the distances. So you're literally working out d1 and d2 and taking them away, okay? How do we do that? All we do is we're going to take 400, sub it into this, s, because remember s was relative to the barn, and then we sub it into r, which is the distance from the origin, and we just take them away. And we can do this by storing the values. So what's the best way of doing this without losing accuracy? So what I'm going to do is I'm going to sub it into the x's first. So I'm going to write s 400 and r 400. I'm going to do the I components first, that I can just quickly change them, and then I'm going to store the values. So I have 400, which I'm going to store as A. So I've stored these as A. Now into here, I need to make sure I'm in radians, so I am minus 28 sine of pi A over 720. So I get minus 2757, dot, dot, dot. I'm going to store that as B. Store that as B. Now I can easily go back and sub it into here by just doing 12 minus. 12 minus, what? Syntax error? Where's my extra bracket? Huh? How's there a syntax error? That doesn't make any sense. There's no faulty brackets. That makes no sense, dude. Okay, let me go back. So I get, wait, why is it bugging out? Store, what have I stored as A? 400. Yeah, it's minus 28. Ayo, guys, this is still the best calculator ever made, by the way. Plus 12. Minus 15. Okay, now it works. Minus 15.57, dot, dot, dot. I'm going to store that as C. All right, now I'm going to sub it into this one. So I get 40 minus 40 cos, which actually doesn't change for any of them, right? Pi A over 720. 46.94. So for both of them, 46.94. 46.94. I'm going to store both of those as D. All right. Now the next thing is we just need to do Pythagoras to them and then take them away. Okay? So it says, find the distance between the balloon's distance from the barn and its distance from the origin. So it's not saying what's the distance between these two, yeah, which wouldn't even make sense anyway. I'm yapping. So you got modulus of S. So that I'm going to do root B squared plus D squared. Then I've got modulus R, which is root C squared plus D squared. So I got root of B squared plus D squared, 54.44. I'm going to store that as E. Storing values is so clutch. So root C squared plus D squared is 49.46 dot, dot, dot. I'm going to store that as F. Store as F. So now I'm going to do E minus F. And then I'll round it. So alpha E minus alpha F, 4.98. So about 4.98 meters. Nice. Find the velocity v of the balloon in terms of t. Okay, I don't think I'm going to need this. Suppose one circuit. Okay, yeah, I'm not going to need that, so I can rub that out. So to work out the velocity is super simple. We just differentiate, yeah? So just differentiating. Technically speaking, it doesn't matter which one you differentiate because when you differentiate the 12, you end up just losing it regardless, right? So this is just a question of, do you know how to differentiate? The answer, I hope you guys, is yes by now. If not, you still need to watch my previous videos. So V is dr by dt, which is, the 12 goes, we get minus 28, that's the multiplier, times. Now, how do we differentiate this? You differentiate the angle first. Pi over 720t just differentiates to pi over 720. Then sine differentiates to cos. Then the angle stays the same, innit? We'll simplify that in a sec. The next one, the 40 disappears. The minus 40 is a multiplier, so that doesn't do anything. Times differentiate the angle is pi over 720. Then cos differentiates to minus sine. That makes this positive. Sine, then the angle stays the same. So my velocity then is 28 over 720. 28 divided by 720 is 7 over 180. So you get minus 7 pi over 180 cos of pi over 720t. Then 40 divided by 720 is 1 over 18. So we get pi over 18 sine of pi over 720t meters per second. Cool. Suppose one complete circuit of its flight takes 24 minutes. Find the times the balloon is moving purely in one direction. Big up Zaymalik and that. So, one complete circuit is 24 minutes. Everything is in seconds. So this is basically telling us the range, isn't it? So our range for t is between 0 and whatever 24 times 60 is, 1440. Now what does it mean that find the times the balloon is moving, so velocity, purely in one direction? Purely in one direction means it's either moving horizontally or vertically. So we need to figure out when this is moving, where it's either doing this or this. Well, that just means one of them is going to be 0, okay? So if we're moving purely horizontally, it means the j component has to be 0, okay? So for the horiz, we're saying the j component is 0. The vertical component has to be 0. So we're just going to say pi over 18 sine of pi over 720t is 0, which basically means that goes, and we need to modify the range. Timesing all that by pi and dividing by 720, isn't that just 2? Yeah. So our modified range for both situations is 0, pi t over 720, and 2 pi. Hopefully you guys can see that over there. It's not getting cut off. So we divide by this, that's all cool. Then we inverse sine of 0. We're left with pi over 720 t is, inverse sine of 0 is 0. Then, how do you work out the secondary value for sine? You do pi minus. Pi minus 0 is just pi. Then you add and minus 2 pi to get your other values. Now when you do 0 plus 2 pi, you get 2 pi. And when you add, you're going to go out of the range. So to all of these, we can divide by pi, and times by 720. So we're going to get 0. So at the start, I assume the balloon's just doing this, isn't it? And then we just times, what is that, 1 times 720. What was it? Doing this. Wait, that was when it's moving horizontal. I don't know. Somehow the thing's landing horizontally, but this is just the maths. 720 and 1440, isn't it? Because that's going to be 2 times 720. They didn't really specify, but they did give minutes. So I'm wondering if it's good if we divide by 60. So t is 0, 12, and 4, that's 24 minutes, isn't it? Yeah, 24 mins. Then the last one is when it's traveling vertically. Maybe they're just making people jump off this balloon. I mean, I did just make it up. So we have that being 0, which again, you cancel off that. We have cos of pi over 720t is 0. Inverse cos of 0 is slightly different now. We get pi over 2. How do you work out the secondary value for cos? You do 2 pi minus. 2 pi minus pi over 2 is 3 pi over 2. Then we're not going to add and minus 2 pi because those values are not going to be in our modified range. So we can divide through by pi, which is 1 and 3 over 2. And then we're going to times by 720. So we have 720 divided by 2, which is 360. Yep, just checking in it. And then 720 divided by 2 times 3 is 08 or 1080. So let's put that in minutes. 360 divided by 60 is 6 minutes, but you can never be too sure these days. 6 and 1080 divided by 60 is 18 minutes. And those are your answers. So I wouldn't say it's harder than the last one I did, but, you know, difficult, maybe nonetheless. It's one of the more tough questions they can ask on vector variable acceleration. So I'd appreciate, guys, if you hit the like button if you learned something today. Subscribe for more maths content. If you're interested in my A-level maths courses, link and details in the description. Feel free to join the Lund Gang Reddit if you want to join the community and submit your own questions for feedback. And yeah, I'll see you guys in the next video. Nice.